Solve the following system equations for all three variables. Okay, so to do this, we're going to want to look at which variable makes the most sense to eliminate first. And in this situation, we can see that the variable most aligned would be the x's, because we have 2x, 2x, and a negative 2x, which means that we can set it up to eliminate our x's first. So we can say 2x plus y plus 2z is equal to 2. And we want to match up this first equation with the last one because it has a negative 2x. That way, when we add them together, we will cancel out the positive 2x and the negative 2x. And then we're going to do the same idea with the second equation and the third equation, where we have 2x minus 7y minus 8x is equal minus 8z is equal to negative 2. And then again, we're going to align it with that third one to eliminate the x variables. Plus 3z equals 8. All right, and we're going to set these up and see what we come up with. So when we add the set on the left, the two x's will cancel out. Y plus 4y is equal to 5y plus 5z is equal to 10. And then on the right here, the positive 2x and negative 2x will cancel out. And we're left with negative 3y minus 5z is equal to 6. And we'll see here that we've now eliminated the x variable in both equations. So we're going to want to set these up together, and we'll see now we're more in like an algebra 1 realm where we're doing a system of two variables. So I'm going to align these up. So we have 5y plus 5z is equal to 10, and negative 3y minus 5z is equal to 6. And we'll see here already that we don't need to manipulate either of these equations at all because the z's will automatically cancel out. So if we see here, the 5z and the negative 5z cancel out, and this will leave us with 2y is equal to 16. Then we can divide both sides of the equation by by 2, and we'll be left with y is equal to 8. So we have one of our variables, we have y, and now we're going to want to go through and find our other variables. So if we look at our steps before up in this row, we'll see that we have equations where we have a y and a z. So let's use these to now solve for z. We can use either equation. I'm going to use the red one. So 5y is 8, so 5 times 8 plus 5z is equal to 10. And 5 times 8 is 40 plus 5z is equal to 10. We can subtract 40 from both sides. So we can subtract 40 from both sides. And we'll be left with 5z is equal to negative 30. And if we divide by 5 on both sides, we'll get that z is equal to negative 6. So now we have our y value, we have our z value, and now we want to go through and get our x value. So to get our x value, we're going to have to go back to one of the three original equations. It doesn't matter which one. I'll just pick the first one. So we have 2x, we're still looking for x, we don't know what that is, plus y is 8, plus 2 times z, which is negative 6, is equal to 2. So we get 2x plus 8 minus 12 is equal to 2. And we can simplify, so 2x minus 4 is equal to 2. And now we're just doing inverse operations after we've combined like terms now. And we get 2x is equal to 6. And then we'll get that x is equal to 3. So if I want to write my final answer, it's going to be the solution of 3, 8, negative 6.